Hello and welcome to Kangaroo Competition in Mathematics. We will solve questions in 2021. Let's start with question 1. Question 1 here. Walid has 6 bricks as shown above. Which of the following solid shapes can be made with his 6 bricks? So we have 2 white bricks and 4 gray. Now we have those 5 choices. Which one of them is the right one? Since I have only 2 white bricks, I can check shapes or options that has only 2 white bricks. This one, option 8, has 3. This one has 1, 2, 3 again. 1, 2, 3 again. 1, 2, 3 again. So D is the right answer, which has only 2 white bricks and the rest are gray. Let's move to question number 2. Question number 2 here. We have few kids here. In how many places in the picture are 2 children holding each other with their left hands? What's the meaning of left hands? That means they are shaking hands. We're usually shaking our hands using right hand with the right hand. Now they want us to find which one or which 2 children here can shake their hands using left hands. So let's see. That means their position will be opposite to each other. Where are the opposite position? Those, they have the same position. So the first position is here. They are opposite to each other. Same position. Those are opposite position and opposite position. Now check their hands. Those are using their right hand. Here, right hand, shaking. Here, again, right hand with right hand. See here. This is her left hand, and this boy, he shaked the girl hand with his also left hand, so it's only one position, so A is the right answer. Let's move to question number 3. Question number 3 here. In the square, you can see the digits from 1 to 9. A number is created by starting at the star, following the line and writing down the digits along the line while passing. So there is a starting position, started with the star, then you need to move, following the line, and you can create a number with a number of digits. Now, for example here, let's see this example. This example started here. So the number starts at the star here. That means the first digit is 4. Then it moves diagonally like this. So it moves to number 2. Then 6. Then here down 8. Then up to 5. Similar to that example, we have to see the question. Which of the following lines represents the largest number? How can I make a largest number from 1, 2, 3, 4, 5, 6, 7, 8, and 9? Definitely, we have to start with 9, then 8, then 7, and so forth. So, let us check the options down here. Which one starts with 9? Where is the star? The star here doesn't start at 9. Also D. Here, C. Those 2 options only started at 9. So let's see the next digit. They moved to 8, both of them. Then this number moved to 6, while this number moved to 5. So which one is bigger? Definitely E is bigger because we have 9, then 8, then 6. Regardless what are the next few digits. So E is the right answer. Let's move. Question number 4. Interesting question. Let's see here, we have boxes 1, 2, 3, 4, and 5. Let's see the question. Safa wants to write the word K-E-N-G-U, Kango, by using letters from the boxes. She can only take one letter from each box. What letter must Safa take from box number 4? So, since I can use one letter only from each box, that means I need to start with box number 3. It has only one letter, sorry. So, let's write K, E, N, G, and U. Now, letter N from box number 3. What comes next? I have 2 letters here and 2 letters here. From this letter, from this box, N is already taken, so I will take E from box number 1. Then move to box number 5. I took E from box number 1, so I will take U from box number 5. Then box number 4 now, U is already taken, E is already taken, N is already taken. Now G will be the letter that I can have from box number 4. So letter G is the right answer. Move. Go to question number 5. Question number 5 is like a puzzle. Let's see. We have 2, 0, 2, 1, and plus. When the 5 pieces shown here, when they are fitted together correctly, they form a rectangle with a calculation on it. So there is a rectangle as a result. What is the result of this calculation? So I can guess that it's addition, but we need to know what is the answer of this addition sentence. They said that I can make a rectangle as a result, so a rectangle has edge and another edge from here. So this side and this side will be on the sides like this here and here. So let's start. Plus will be in the middle. And you have to start with 1 and ends with 0, because those are the 2 ends of the rectangle. Now let's see, since I used this one, I used this one, and I used this one, I need to see what would be the answer, possible answer here. Now what you have to see the open ends here, the ends of each piece of the puzzle. How can we arrange them? Now this one is opened here, like this. So, and this one here makes like this, both sides. So I need open side and closed side. This one can fit here. Now this one will be the opposite. It will be opened because one here is opened. So I need the other one that can fit here. So this is 12 plus 20. 12 plus 20 makes 32, and 32 is the right answer. Add 12 and 20, that makes 32. Moving to question number 6. Now, question number 6, here we have a measuring tape which is wrapped around this cylinder. Which number should be at the place shown by the question mark here? Let's see options: 53, 60, 69, 77, and 81. Let's see. 6 on the second round, 27. Then there must be a number here, and my targeted number must be here. So I have to follow the pattern. What's the pattern? 6, then 27. What happened here? We added 21. So I'm adding 21. So let's add 21 plus 27. That gives you 48, which is the expected number on the second round or the third round. Now, after 48, I have to add more 21. So adding 21 more here, you will have 69. So C is your answer, 69. Moving to the next question. Are you ready? Let's move. Question 7. Can you see this figure here? This figure, here it has inside 5 figures, A, B, C, D, and E, on that grid. So the 5 figures on the grid can only move in the directions here indicated. So left, right, up, and down in 4 directions. Which figure can leave through the gate G? So let's check the gate. The gate has 1, 2, 3 squares that I can move to go out of the gate. Now let's see this dimension here. Can A fits here? Can it leave? Let's see. This one can move, but 1, 2, 3 can move, but it will stuck here. So it will be stopped here. Here I have 1, 2, 3, 4. It can't leave. It cannot go out of the gate. Let's see. C. Definitely C is not, because 1, 2, 3, 4. It has 4 squares. It cannot go. E. This will move. 1, 2, 3 will move, but the gate will stop those 2 here. Moving to D. This will move up. Then 1, 2, 3. It will move. Then it will stop here because I have 1, 2, 3, 4. Those cannot leave. Let's see B. 1, 2, 3. They will leave. Then 1, 2, 3. They will be up. Now they will stuck here. But if you make a shift like this, 1, 2, 3 again can move up and leave the gate. So B is the right answer. Question 8. Question 8. Now, Selma is going to paint the walls in her room green. The green paint is too dark if she only used the green color. So she mixes it with white paint. She tries different mixtures. Which of the following mixtures will give the darkest green color? So let's see the options here. She used 1 part green, 3 parts white, 2 parts green, 6 parts white, 3 parts green and 9 parts white, 4 parts green, 12 parts white, or they will be all equally dark. Let's see the options. Since I have parts, that means I can use those as fractions. So let's see. Those are out of 4 parts she used. Those are the green and those are the white. So from the first option, 1/4 green, 3/4 white. Next, I have total 8 parts. 2 out of 8 and 6 out of 8. Next, 3 out of 12 and 9 out of 12. The last combination will be, those are also green and white. Here we have 4 out of 16 and 12 out of 16. Now, let's check. Quarter, 3/4. Now, I can see that I can find some equivalent fractions. Equivalent fractions to the first option here. Find the equivalent fraction. You will divide by 2. That makes a quarter, which is the same here. Again, this one is an equivalent fraction to this. 3/12 or 3/12. Again, it's an equivalent fraction to the first combination. 9/12, the same. It's an equivalent fraction. If you divide by 3, you will have 3/4. Divide by 3. Here, divide by 3, you will have 1. Divide by 3, you will have 4. And the last option, which is 4/16. Divide by 4. 1. Divide by 4. 4. Divide by 4. 3. Divide by 4. 4. So all of the options given here, all of them, they are equivalent to each other. That means they will be equally dark. There's no difference between the first, second, third, and fourth option for the combination of the colors. So they will be equal. Now let's move to question 9. Question 9. Let's see, here we have a grid and we have those shapes, and let's see what's the story behind this question. Maryam had a piece of paper. She folded it exactly in half. Then she folded exactly in half again. So half, then another half. So she got this shape. This is a triangle. Now, which of the shapes, P, Q, or R, here, was or could have been the shape of her original piece of paper? Now, let's see. If she had the P shape here, which is the rectangle, if she folded the rectangle here around the line of symmetry, it will be a square. Then let's imagine that she will fold the square around this line of symmetry. The result will be the triangle. Let's see if this is applied here on that shape or on Q shape or on R shape. Let's do the same. If she folds this shape around the line of symmetry here, it will have, or she will have, this triangle. And if she folds it again, if she folds this again around this line of symmetry, this will be the result. The first shape, and the second shape. Let's check the last one. The line of symmetry is here. So if she folds the shape around this line of symmetry, the shape also will be here. So again, the same triangle. That means E would be the right answer. Any of P, Q, or R could have been the shape of her original paper. And question number 10. Question number 10. Let's see. There is a square with line segments shown inside it. So we have many line segments inside each of those squares. The line segments are drawn either from the vertices or the midpoints of other line segments. So either from the vertices or from the midpoint of other line segments. Now, we colored 1/8 of the large square. Which one is our coloring? So It's the fraction of the large square. Which one is the right choice? This one is impossible. So small to be an eighth. This one also cannot be. Also, this one is wrong. Now let's see this one here. This one here, if you check, this can be part number 1, that one, part number 2, and if we imagine that we have a line here, so this is part number 3 and part number 4. So the colored fraction is 4th, which is not 8th. This one again, it's 4th of, or a quarter of the square. So this one would be the right answer, but let's explain why. This one, 1. The other part, which is 2. Imagine the line here. Again, 1, 2, 3, 4, 5, 6, 7, and 8. So those are 8 equal parts, and we can tell that this green part is 1/8 of the square. تمام. Question 10. لهون إن شاء الله رح نوقف بهذا البارت عند question 10، ورح نكمل إن شاء الله في السيشن القادم على starting question 11 من أسئلة الكنغارو. نراكم على خير.